Work out the 2 by 2 matrix that represent each of the following transformations. So first of all, we're going to do a rotation through 270 degrees about the origin. So I want to find the matrix, the 2 by 2 matrix that represents that transformation. To do this, I'm going to think about the unit square. So that is a square that looks like this, where this is the coordinate 1, 0, and this is the coordinate 0, 1. And I'm going to think about what happens to each of those coordinates under this transformation. So what happens to the coordinate 1, 0, and what happens to the coordinate 0, 1? So let's have a think about that under this transformation. So a 270 degree rotation about the origin. So 270 degrees. So that's 90, 180, 270. So this point 1, 0 gets rotated 270 degrees and becomes the coordinate 0, minus 1. The point 0, 1 gets rotated 270 degrees and becomes the point 1, 0. This allows me now to write down the first column of my matrix will be 0, 1. Sorry, 0 minus 1 because of this column vector there. And the second column will be 1, 0. So this matrix here does represent the rotation 270 degrees about the origin. Question 2. Let's do the same thing. I'm going to think about what happens to the unit square and what happens to the points 1, 0 and 0, 1 under the transformation where it's an enlargement scale factor 3. So that's going to make this square 3 times bigger. So it's now going to look like this, where this here is the point 3, 0, and this point here is the point 0, 3. So the coordinate 1, 0 has been mapped to 3, 0, and the coordinate 0, 1 has been mapped to 0, 3. So that allows me to now write down the matrix for this transformation as 3, 0 from here and 0, 3 from here. So this is how we can use the unit square to find a matrix for a transformation. Just think about what happens to the coordinate 1, 0. This tells you the first column of your matrix. And then think about the coordinate 0, 1. This tells you about the second column of your matrix. Let's do another example. So in this example, we're told that the unit square, OABC, is transformed by the matrix minus 1, 0, 0, minus 1 to O, A dash, B dash, C dash. We need to show the image on a diagram labelling each vertex. So my usual unit square, OABC, would look like this. This is my original unit square. And I can see from this transformation that my point 1, 0, so this point here has been mapped to the coordinate minus 1, 0. So that's been mapped to be over there. And I can see from this column here that my coordinate 1, 0, 1 has been mapped to be 0, minus 1. So therefore, my new unit square would look like this. This is the image. This, I can see, is going to be a rotation. The question's not asked me to state this, but I'll just do it anyway, just for you, hopefully to help your understanding. This black square has been formed as it's a rotation of 180 degrees around the origin. Because I can see that this point here has been rotated 180 degrees to there, and this point here has been rotated 180 degrees to there. So this matrix represents a rotation of 180 degrees around the origin. So like I say, an understanding of the unit square and how this point corresponds to the image of the point 1, 0, and this point here corresponds to the image of the point 0, 1, can really help you with either interpreting what a matrix represents or finding the matrix from the transformation.